Hi pre-calc. So you only need to watch the first page of this video. I am going to continue on just in case someone is absent during class time, but we will do the second page in class. All right, so we're looking at the composition of two functions. And so notation-wise, notice how there is sort of something inside this other function. So these are your inside functions, and then you have the outside function. And when you are doing compositions, you always start on the inside and work your way out. So how do we say this? Notice we would say this as this is f of g of x, and sometimes we also write it with the little open dot. It's an open dot so it doesn't get confused with multiplication. Down here you'd have g of f of x. And the main thing, this is really just fancy notation for substitution, which is basically what you're doing, substituting a function into another function. However, when we have restricted domains, you are going to have to pay attention to whether what you are inputting is in the domain. So let me kind of write that out for you here. So always check that your input is in the given domain for what you're putting it into, in the given domain. And we'll do some examples so you can see all the different possibilities that might arise. All right, so we have these two functions, g of x and f of x. They each have some restrictions on their domain. So we want to find f of g of 6. And again, when you're watching a video, it's not a bad idea to kind of pause the video and try an example on your own and then start it up just to see if you got it right. So since we're going to start on the inside, we're going to first find g of 6, and 6 is within the domain of g. So when we plug 6 into the function, we get 6 minus 3, which is 3. So then we move to the outside function. So f of this now goes inside here, f of 3, and 3 is inside the domain of f, so we're good to go. So negative 2 times 3 plus 8 is going to give us an answer of 2. So f of g of 6 equals 2. All right, let's do another one. So we have g of f of 6. So we start with f of 6, and we look at the domain, and f of 6 does not exist, so yay. 6 isn't in the domain of f, so you're done. That's always nice, because we get to then move on. All right, let's find g of f of 1. So that means we start on the inside. F of 1 is in the domain of f, so negative 2 times 1 plus 8 is 6. All right, all is good so far. So then we go to g of 6, and that is okay as well. So remember, this 6 went in here. So we have 6 minus 3, and that gives us 3. So no problems there. We keep going. Find f of g of 2. So g of 2, again, g of 2 is fine. So we find g of 2. 2 is in the domain. 2 minus 3 is a negative 1. So now I'm going to find f of negative 1, but notice that negative 1 is not in the domain of our f function. So sometimes you are going to find it doesn't work on the first function. Sometimes it's going to not work on the second function. Now let's kind of get to where it really gets interesting. So you're doing it as a function. Now finding the composite function isn't hard. It's finding the domain and range of this composite given you had restrictions. That's where it gets interesting. But just doing the composite is not bad. So we're going to take f of x, and it's going to get substituted into g. So what I like to do is I like to start off with, so this is going to be g of, and what's going to get plugged in is negative 2x plus 8, because that's your f of x function. So I like to make a template out of my g. My g is x minus 3. So it's going to be something substitutes for x minus 3. So what goes there is what's in the parentheses, negative 2x plus 8. Like I said, it's just substitution. So simplifying that, we have negative 2x plus 8 minus 3. That all simplifies to negative 2x plus 5. Okay, well, no problems there, right? But now we have to look at figuring out what is the domain and range of this new function, because it looks like a linear function. It looks like, hey, everything should be all reals, but that's not going to necessarily be the case. So we start off with, we've got g of f of x is what we just found, and that was this function up here. Here was our g of f of x. All right, so the outside function is going to determine the outside of our inequality. So g has a domain that goes between 2 and 7. What goes inside that domain now is f of x. So what this turns into, f of x, sorry if I'm not being consistent with coloring, f of x is negative 2x plus 8. And so what we have to do here now is isolate x inside our inequality. So I subtract 8 from both sides and then divide. Well, I'll do it step by step. Negative 2x, subtract 8 from both sides, negative 1. Then we divide by a negative 2. Remember that when you divide by a negative, your inequalities are going to change. So negative 6 divided by a negative 2 is a positive 3. Negative 1 divided by negative 2, this turns into 1/2. That is not our standard form for writing an inequality. We tend to have the lower number on this side, so we're going to switch things so it kind of makes sense. So here, it looks like that's a potential candidate. It's not necessarily our final answer here. So let's look at if I made a number line. And on this number line, I'm going to put the domain of my original function. Actually, what I'm going to put on this number line, let me extend it here, is what we just found. We found 1/2. Here's 1/2. And here is 3. I should probably 1, 2, 3. And then I also want to put on here, compare that to that inside function f of x. F of x went from 1 out to 5. So this was the inside function, because remember, the first thing you do is put something into the inside function. So it's got to be within that inside function. But we just found a composite that went from 1/2 to 3. So what you are looking for is the overlap of those two, the inside function, which in this case was f of x, and the composition domain, and find that intersection. The intersection is going to be from 1 to 3, because 1/2 is outside the domain of f of x, so you can't, that's the first thing you're plugging into, so you can't plug in a 1/2. 4 or 5 is outside the domain of the composite function, so it wouldn't work. So our final answer here for the actual domain is going to be from 1 to 3, and that would be the actual domain. The range, I should probably label that. The range is now really nice, because to find the corresponding range, all you have to do, because you know everything is okay now, you just plug in those endpoints into your composite. So that means we're going to be plugging in I'm going to do it over here to the side. So negative 2x plus 5, that was our composite function. So negative 2 times 1 plus 5 is 3. Negative 2 times 3 plus 5 is negative 1. So the corresponding range is going to be from negative 1 to 3. And again, there's two different ways. You can write it here with the inequalities. You can also write it with the brackets. So I could have also written my domain as square brackets because we are including the endpoints. If I had done a soft parenthesis type bracket, that means it's open at the endpoints. So this might be an easier way for you to write it. Okay, let's do this one more example. And then you can stop watching the video because we'll complete the next page in class. So over here I have find f of g of x. We're doing example F. So if I go back up, we're going to now take g of x and plug it into f. So this is going to be f of x minus 3. And so that means I'm going to be taking negative 2 times something plus 8. X minus 3 is going to go in there. And then we simplify. So that's going to give me negative 2x plus 6 plus 8. So our composite function is negative 2x plus 14. Now again, we go through, this is a good place for you to pause to see if you understand that concept of how to find the true domain of the composite function. We're finding the domain of f of g of x. So again, the domain of f, because it's outside, goes on the outside. And then g of x as a function goes inside, and we solve for x. So this one's an easy one. We add 3 everywhere. Here's x, we add 3. Again, maybe you should put like a parenthesis. This is a potential. So now we want to compare. We compare 4 to 8. So 4, 5, 6, 7. This was our composite function, f of g. And we compare that to the inside function, because the inside function is our first candidate for what we're going to plug into. G of x goes from 2 to 7. So from 2 to 7 is g of x. The overlap is going to give us our actual domain. So the overlap is going to be from 4 to 7. So my domain is going to be all the x from 4 to 7. And again, to find the corresponding range, it's a little bit easier. All we have to do is plug our domain endpoints into the composite function. So I have negative 2 times 4 plus 7. So that's going to give me, did I do that right? 7 minus 8 is negative 1. Oh, that's a 14. Okay, I knew there was something wrong there. 14 minus 8. 14 minus 8 is 6. And then we go negative 2 times 7 plus 14, which is going to give me 0. So my range is going to be 0 to 6. Okay, that's it for now. We will finish the rest tomorrow. Okay. So this is actually, I was going to be putting you into breakout rooms to check that you understood from the first examples, and then just have you work these 2 examples and come back and see how you're doing. So if you please, you don't have to watch this right now. We're going to do it in class. This is for anyone who might be absent. So first thing I'm going to do is actually find the function. Since we're finding f of g of x, f of x plus 2 is going to be 2 times x plus 2 minus 1. That gives me 2x plus 4 minus 1. So this function will end up being 2x plus 3. We'll be able to, or we're going to need to use that later. So now we want to actually find a potential for our domain. So the outside function goes here. the inside function goes here. And so f had negative 16 to 2. And we solve for x, so subtract 2, negative 18. And this becomes 0. So we have a potential candidate that goes from negative 18 to 0. And the function for the inside function, because that's kind of like your first line of defense, goes from negative 11 to 17. So we are comparing that to this, and what we want is the intersection, which is going to be from negative 11 to 0. So my domain will be negative 11 to 0. And the corresponding range is what you plug into your composite function. So we're going to have a negative 22 plus 3, which is going to give me a negative 19, and plugging in 0 is going to give me 3, so my domain is from negative 19 to 3. And again, that's plugging it into your composite function. All right? Let's try doing it the other way, g of f of x. So g of f of x, we also want to find that function. So this is g of 2x minus 1. So that's going to be 2x minus 1 plus 2, which gives us 2x plus 1. You need that when you're finding your range because you have to plug it into that composite function. All right, so my outside function is now the g function. So that means I have a negative 11 to 17. What goes on the inside is your inside function, 2x minus 1, and we're going to solve for x. So I'm going to be adding 1 everywhere. Add 1. This becomes negative 10. Divide, so that gives me 2x. Divide everything by 2. Luckily, I don't have to change my inequality. And divide by 2. So I have negative 5 to 9. So now we have to look at our candidate for our domain. So this told me from negative 5 to 9. That would be your composite. But the original inside function, which was our f of x, went from negative 16 to 2. So this was the inside function f of x. The overlap is going to be from negative 5 to 2. So my domain is going to be from negative 5 to 2, and the range is going to be what I get when I plug that in. So negative 10 plus 1 is a negative 9, and 2, plugging in 2, 4 plus 1 is 5, so this will be from negative 9 to 5. Now, what we did here was showing a given restricted domain. Sometimes functions have built-in restrictions, such as square root functions, and then you don't actually have to be given anything. You just have to understand it's part of the equation. So we have a problem down here. Given f of x is the square root of x minus 5, hopefully you realize the domain means that x has to be greater than or equal to 5. That's a built-in restriction. And then we have g of x is x squared minus 4. That one actually has a domain of all real numbers because it's a quadratic. So they want us to plot the graph f of x, g of x, and f of g of x on the same graph. And again, if you're not sure how to graph these, I will go over it, but you also can use Desmos when you're doing this. Okay, let's find, what is it, f of g of x. Let's actually find that. So f of x squared minus 4, so that's going to be x squared minus 4 minus 5, which will give me the square root of x squared minus 9. All right, let's graph these puppies. Square root of x minus 5, so f. I will do f in green. So we know that 5 is going to be the smallest number possible. So 1, 2, 3, 4, 5. It's going to be here, and it will look something at 2, it would go up to, I'm just going to kind of estimate it, it's good enough. If I went out 1, 2, 3, 4, it would be at 2, so it's going to hit like that. Okay, so there's f of x. G of x, I'll do that one in pink. X squared minus 4, so it's basically a parabola that drops 4 units, 1, 2, 3, 4. That's why we like knowing our transformations. Over 2, 1, 2, 3, 4. So I'm going to actually cross at these intercepts. So there's my g of x. And x squared minus 9 is, you might not be aware of this, it's almost like you guys did 4 minus x squared, which was the top half of a circle. This is that same idea, but it's been exploded. So our composite function is going to look like this. It's going to be here at 3, and it's going to go, it's also going to kind of go out like this, and it's also going to be at -3, and it's going to go out like that. Because it actually has, because you're squaring the x, if I plug in a -3, I get 0. If I plug in a -4, I get 16 minus 9. So you have the 2 branches of that function. Again, you can use Desmos to kind of see how those work. So finding the domain, we can look at the graph, which is nice to kind of figure out what this domain is of the composite function. Notice that x is going to be less than or equal to a -3, or x is greater than or equal to 3. You can also write that as the absolute value of x is greater than or equal to 3. Those are 2 ways of writing the domain of that composite function. And we can get that just by looking at the graph. Okay, explain why the domain of f of g of x has positive and negative values, whereas the domain of f only has positive numbers. So the reason for that is that our inside function was, because we did f of g, so the inside function, which was g of x, has no restrictions on the domain. On its, I'm going to say just domain. And when you plug it in, it makes all the positive numbers, it makes actually all the negative numbers you plug in positive. So everything turned out to be okay. We could have both. Now, show algebraically that f of g of 4 is defined, but f of g of 1. So this is kind of like what we did on the previous page. So I'm going to start with f of g of 4. So g of 4 is going to be 16 minus 4, which is 12. So f of 12 is going to be the square root of 12 minus 5, which is the square root of 7. All right, all is good there. We were able to plug it in because 12 was in the domain of f. Now let's go the other direction. F of g of 1. F of g of 1. So first thing is g of 1 we want to find. G of 1 is going to be a -3. And since -3 is not in the domain of f, we don't have an answer there. All right. If I were to plot the graph of g of f of x, let's see what that looks like, including positive and negative y values. All right, so let's choose a couleur. I sure didn't give a lot of room here, did I? So we're doing g of square root of x minus 5. When I plug it in, that input is going to get squared, so I end up with x minus 5 minus 4. It looks like just the equation of a line. So I'm going to go down to, this was at 4, 5, 6, 7, 8. Here's -9 is my y-intercept with a slope of 1. And that would be the graph of g of f. So the graph g of f of x appears to be a straight line. Find an equation for g of f of x explicitly in terms of x to determine whether this is true. And I'm not quite sure, obviously we already did it. It's right there. We have that g of f is x minus 9. Yeah. Okay. I hope this works.